Good day everyone. So in this video, I will present a discussion of statistics and its most important formulas. Statistics is a branch of mathematics that deals with collecting, organizing, presenting, analyzing, and interpreting data. These statistical tools help us understand information clearly and make correct decisions in real-life situations as education, business, science, and research. In this discussion, I will explain each formula, what it means, and when it is used. Statistics is used whenever we work with data. Data are facts, figures, or informations collected or analysis. For analysis, statistics helps us summarize large amounts of data into meaningful values that are easy to understand. There are two main types of data. The first is qualitative data, which describes qualities or characteristics such as color or type. The second is quantitative data, which involves numerical values. Can be classified into discrete data, which are countable, and continuous data, which can take any value within a range. Measures of central tendency describe the center or typical value of a data set. The three main measures are the mean, median, and mode. The mean, also called the average, is calculated using the formula x bar equals the summation of all data values divided by the number of observations. Here, x bar represents the mean, sigma x is the sum of all values, and n is the total number of observations. The mean gives us an overall idea of the center of the data, but it can be affected by extreme values or what we call outliers. The median is the middle value of an ordered data set. To find the median, we first arrange the data from the lowest to highest. If the number of values is odd, the median is the middle value. If the number of the values is even, the median is the average of the two middle values. The median is useful because it is not affected by outliers. Now, the mode the mode is the value that appears most frequently in a data set. A data set may be unimodal if it has one mode, bimodal if it has two modes, or multimodal if it has more than two modes. Some data sets may have no mode at all. Measures of dispersion describes how spread out or varied the data values are. They help us understand how much the values differ from each other. The range is the simplest measure of dispersion. It is calculated by subtracting the lowest value from the highest value. The average range, the range gives a quick idea of how wide the data values are spread. Now, let's dig into variance. Actually, the variance have two types, the population variance and the sample. Population variance is calculated using the formula sigma squared equals the summation of x minus x bar squared divided by n. In this formula, x represents each data value, x bar is the mean, and n is the number of observations. Variance measures the average squared distance of each value from the mean. When working with a sample instead of an entire population, we use the formula s squared equals the summation of x minus x bar squared divided by n minus 1. Dividing by n minus 1 helps give a more accurate estimate of the population variance. Standard deviation is the square root of variance. The formula is sigma equals the square root of summation of x minus x bar squared divided by n. Standard deviation tells us how much data values typically deviate from the mean. A small standard deviation means the values are close to the mean, while a large standard deviation means they are not or they are more spread out. Quartiles divide an ordered data set into four equal parts. The first quartile or Q1 represents the lowest 25% of the data. The second quartile or Q2 is the median. The third quartile or Q3 represents the highest 25% of the data. Interquartile range is calculated by subtracting Q1 from Q3. It measures the spread of the middle 50% of the data and is useful for identifying outliers. Percentiles divide the data into 100 equal parts. The formula for percentiles is P sub k equals k over 100 times n plus 1. Here, k represents the desired percentile and n is the number of observations. Percentiles show the relative position of a value within a dataset. For example, the 90th percentile means that 90% of the data values fall below the point. Deciles, on the other hand, divide the data into 10 equal parts. The formula is d sub k equals k over 10 times n plus 1. Deciles are commonly used in analyzing income distribution, and academic performance. Probability measures the chance that an event will occur. The formula is P of A equals the number of favorable outcomes divided by the total number of possible outcomes. Probability values range from 0, meaning impossible, to 1, meaning certain. The z-score formula is z equals x minus x bar divided by sigma. A z-score tells us how many standard deviations a value is away from the mean. A positive z-score means the value is above the mean, while a negative z-score means it is below the mean. The correlation coefficient measures the length and direction of the relationship between two variables. Its value ranges from -1 to +1. Values close to positive and indicate strong positive correlation, while values close to -1 indicate strong negative correlation. The regression equation y equals a plus bx is used to predict the value of one variable based on another. In this formula, b is the slope and a is the intercept. Regression analysis is widely used for prediction and trend analysis. Skewness describes the shape of a data distribution. A positive skew means the distribution is skewed to the right, while a negative skew means it is skewed to the left. If skewness is 0, the distribution is symmetrical. Now let's go to the final and the last one, the kurtosis. Kurtosis measures how peaked or flat a distribution is compared to a normal distribution. High kurtosis indicates a sharp peak, while low kurtosis indicates a flatter distribution. In conclusion, statistics provides powerful tools that helps us summarize data, measure variability, compare values, and analyze relationships. Understanding these statistical formulas is essential for research, academics, and everyday decision making. Thank you for watching, and I hope this discussion helped you better understand statistics.